Okie dokie, so today I'm talking about inducible operons. These are ones that are normally off, but then they turn on. So I'm going to talk about the pieces of it and a general overview of how it works. So first part of an inducible operon is this regulatory gene. Then we have a promoter region, operon, the gene itself and different parts of it, and then the terminator region. So I'm going to start at the front. The regulatory gene. This gene is very special just because it codes for a repressor protein. Spelled protein wrong. And so what's going to happen is the repressor protein will bind to the operator. So I'm going to just place it and kind of draw something that looks kind of funky, but just know that it binds to the operator. This promoter region, I kind of skipped over it, is where RNA polymerase will bind to. So RNA polymerase, and I'm going to draw that like a little onion type looking thing. And this is kind of how an inducible operator stays, and this is kind of in the off position. And so we have RNA polymerase, but it can't go through and transcribe this gene because the repressor protein is in the way. So what's going to happen is you're going to have an inducer molecule, and I'm going to make it a circle, and it'll come in here onto and bind to the repressor protein. This binding will cause a change in the shape of the repressor protein. So let's say it like turns the little spikes out, and then the repressor protein will fall off. And once this repressor protein falls off, then RNA polymerase is going to be able to go through and copy the gene, and then we have our mRNA. And then it can go do its thing and make the protein that this gene codes for. So that's kind of the basic idea of an inducible operon. It's usually in the off state, and then you need the inducer molecule to bind to the repressor protein to turn it on. And so inducible kind of means startable or starting. So it's usually off and it turns on. That's kind of the basics of an inducible operon.